Okay, so generally I'm going to go over the overview. Let's call it an overview of the Maths IA for 2020 and forward. Now, let's start off with the concept. The main thing is that you need to do an investigation. That is the thing that we need to do, an investigation. I would stay away from the concept of that it needs to be a proper thesis. That is not the case. What it does need to have is it needs to describe how you found something and what you found. That is the main concept. There is a couple of things that might be advantageous that IB mentioned. So for example, in your investigation, it might be advantageous for you to mention the way mathematics links to a real life situation. So whatever maths you do, if you can come up with some conclusions as to how it links to a real life situation or your life, that may be useful, but it's a possibility. It depends on what your maths IA is. If you can also, depending on what it is, like I said, where appropriate, make connections to any moral, social, and ethical implications. That's something that IB would also like. International dimensions through history and internationalism can be commented on if possible. And this is the one that I judge to be something useful, not just for the IB, but generally when you are going on to university. This bad boy here, it is essential, in my opinion, it is essential for you to be able to, hold up, I've got a lot of stuff coming up here. My apologies for that. Let's get rid of that and make it something like that. It is essential to appreciate the validity of the methods, data, and conclusions made, because this is a general skill that I judge to be advantageous, which you can get out of the IB once you've done your investigation or during the investigation itself. Okay, so let's just talk about basic considerations. So the first thing we're going to consider is the basic considerations. What have you enjoyed the most in the course thus far? If you have an answer for that, that might aid in the direction you can go in. Generally speaking, the further considerations you need to make is, do you want to do a statistics modeling data type investigation where you gain some values, you gain some data, and you do things with that, you model them, you talk about distributions and statistics and so on? Or do you want to go down a more, let's look at these equations, let's talk about derivations, let's look at that type of thing? Be aware that the latter can sometimes be more challenging depending on your capacity. So it is more challenging, for example, for some to talk about, I don't know, the ways in which you could find, the ways in which pi can be derived from certain methods, or let's talk about different derivations that lead to the same equation, and let's look at the exploration of that. Let's see where that goes. That kind of stuff might be difficult in terms of the requirement to reflect the requirement for personal engagement relative to these research-like ones, wherein these things might be said to be easier. But again, it's very much dependent on your capacity. It's just a warning to suggest these ones where you kind of study a mathematical topic and go into depth with that rather than data can sometimes be a bit more challenging for some. Whether you wish to explore something you have seen in real life, is it true? What does it mean? So that's one way you can go about it. Is there something in a real life situation that you are interested in? Maybe you saw something on television or on a video and you're thinking, is that true? Can I explore that? I didn't really get that. Maybe we should investigate that. Maybe that's something that I can find out. Maybe that's something that I can actually explore, investigate. Or it could be career or other subject related. Right? Maybe it's in physics, it's in chemistry, it's in biology, or just particularly with regards to your career. Maybe you want to go to medicine. Hobby related, of course. And one that I think is done by many is topic that is not covered in your syllabus. With regards to a topic that is not covered in your syllabus, we have to, again, there's a certain sense of challenge that might come with that. But these are some of the considerations you can make. You can begin with this, and then you can go forward to ask yourself some of these questions. Is there a hobby or a sport that you are particularly interested in? Once you've got something that you can suggest as a keyword that you're interested in, what I would do is write out all the related thoughts and ideas related to that. That was a silly sentence because related was in it twice, but you understand what I'm saying. If, for example, you're like, one of the things I'm interested is pollution, and then you could ask yourself, what are all the things that are related to pollution? And then once you have a list of those, perhaps you might even mind map it. So you make a little mind map, find all the connections that you can, and then once you have a list of those, you look at all those connections and ask yourself this question: is there, in terms of these connections, in terms of the related ideas, is there a way that mathematics could be used to model something, to describe it, to prove it, to check it, to further it, to find a correlation, so on and so forth? And in these circumstances, you can start to build a research question, something that you would like to investigate. Your investigation is going to need to be 8 to 12 pages, and it should be broken down, pardon me, into the introduction, the main body, and the conclusion. And that's what I'm now going to discuss in the next section. So what I would suggest is, let's look at this concept of the introduction first. So I'm going to express it in terms of the introduction first, and then from there we shall see how things go. So, right, in terms of the introduction, what is it that I think you need to have? What is it that I think you need to include in that introduction? The first thing is to state the purpose of the investigation. Nice and clear purpose. Why are you doing it? What is that? You could also signpost, which is, in my opinion, I've stated it here, is it might be useful to summarize to the reader the structure and content of the writing. And this is where you can illustrate coherence and logical order. I'm first going to look at this, then we're going to look at that, then I'm going to look at this, and then from there I'm going to make some conclusions as to my results, and so on and so forth. Of course, that was really vague, but I want to keep it vague because I don't want to make this a map wherein you lose creativity in your IA. But generally, it might be useful to give some direction as to where your writing is going. One of the main things I would suggest you make sure occurs is that you have a research question clearly stated as in your introduction. What is it that you're looking to explore? And with regards to purpose, be aware that this leads into the next concept, which is the personal engagement. In this situation, when you're stating the purpose of your investigation, you can state why you are doing it in a manner that is personal to you. So the next thing we're going to look at, therefore, is personal engagement. And this manifests itself in the introduction, the main, and the conclusion. It is advised that you choose a topic that you like and state why you like it. And this is not just as a result of making the personal engagement come out and clear, but it is also just in terms of motivation. If you do something that is not in line with your ideal, who you wish to be in the future, you might find that the workload required to produce 8 to 12 pages on something on an IA like mathematics will mean that you will procrastinate or lead you to procrastination, and then you will definitely not produce the outcome you want. So I would suggest you always spend some time dealing with that first thing I talked about, which is to ask yourself, what have you enjoyed the most in this course? And please ask yourself that even with regards to the other questions, will you actually enjoy going about this topic? It's not per se, I would not be doing it in a manner that suggests just to get the largest amount of marks, or because you've read an IA that is similar and you know how to structure it. Therefore, I would specifically look for something that you're interested in. I said perhaps try and be creative with how you can apply what you have learned back to your real life situation, or what you are doing in real life, or how is it related in the real world. This can be linked with discourse or language that could be described as higher personal engagement. So for example, what you want to do is you want to at times consider, even just in the conclusion, you can consider to what degree has what you have learnt, to what degree can it be applied to the real life situation, to your life, for example, and then you have the capacity to increase, or at least include, or could be considered to be personally engaged. A what if question may be advantageous. You could use these questions to structure your IA, or state one in the conclusion for further research. What I mean by this is, so for example, what if I were to use a different method? What if we were to apply this concept somewhere else? And in this situation, the what if question, if done correctly, and this is just something to consider, it will come out at you once you actually have a research question. What if I was to do something in another way? That could be used to structure your IA, but moreover, it can sometimes be considered to be linked to personal engagement as well, because the degree to which your IA is going to be structured to answer that what if question means that you have made the decision based on your own personal choice in producing that question. That means your IA is specific to you, that your ideas are specific to you. Now, in terms of personal engagement going forward, I would like you to consider historical or global perspectives related to you. So that is to say, your culture, your ancestry, your history. If you have the capacity to consider those things and relate them to why you are doing your investigation, to relate them to your research question. Remember, they need to be relevant, and it's not going to be relevant to all IAs. But if you have the capacity to do that, that can increase personal engagement further still. Okay, now, moving on to the last three parts of this, I would consider this concept of exploring unfamiliar mathematics, so something that was outside of the syllabus. This is something I suggested earlier when I said that you could pick a topic not covered by the syllabus. You could pick a topic not covered by the syllabus. Now, if you do that, there is a danger, and the danger is that I have seen in the past that sometimes it could be more difficult with regards to such things as personal engagement, because the best you can do, given that it is just a topic outside, just for example, you want to do differential equations because you're an SL student and it's not in your topic to the degree you would like it to be, it's difficult to suggest genuine engagement from that, perhaps, unless you want to apply the differential equations to a real life situation that you are going to go into further. It might be difficult to do that. So be careful with regards to just picking on a topic that's outside of the curriculum. Sometimes things like personal engagement can be challenging to blag. It may be useful to consider something that you care about in the real world, so pollution, homelessness, poverty, something that you're generally interested in. That can depict personal engagement relatively well. And finally, some might say make sure personal engagement is obvious in the introduction and conclusion, plus visible at least once in the main body. I would begin with it, I would conclude with it, and I would consider it throughout my investigation. Okay, let's look at the main body, the writing. So this is why, just to remind you here, when I talked about personal engagement, I was considering the introduction, the main, and the conclusion. For the main body, the writing, this is something that I would suggest you consider. First of all, the language should be concise. That means we do not want long, elaborate sentences, and be well checked for spelling and correct sentence, please. That is something that is very important. I think sentences can become very elaborate and awry when discussing mathematics. All steps should be clearly explained. Write out in words the mathematical steps, please. Write out in words the mathematical steps, please. All references are cited. For instance, you can use the APA method. If you're not sure about what that is, perhaps look it up. But all references should be cited. And references can be used to strengthen any arguments or to strengthen any reason as to why you are going in the direction you are going in. It gives you a backup, so please be aware of that. With regards to being concise, I talked about concise in terms of the sentences. Concise can also, or being concise can also be in terms of stay very focused on your aim. I would like you to consider the degree to which you are concise in terms of are you going off topic relative to your research question? It must be linked to your research question. Stick to the signposted structure. So if you suggest how you're going to structure your work, stick to that, please. That is important. That's why I've colored those things the same. Please stick to the signposted structure. It allows for a lowered sense of anxiety from the reader as they are aware where you are going and where you have come from. Use language that implies you are confident, but be aware of the limit of the degree to which you truly know. And this is not a TOK concept per se. This is just a general concept. That is to say, the concept of saying this is something, or this is the value of this, relative to this might be the value of this, or some might say, or we can suggest that. Now, the language that I've just claimed to you in the latter implies that you have some evidence to suggest that you are right, but you are being cautious as to the degree to which it's true. Another way of considering it is, rather than stating that it's 100% true, you imply probability. It might be the case. Okay, stay away from exaggerated and cliche comments. Ever since I was a child, I found E astonishing. This is the kind of thing I've found in the past when I'm reading it. And I'm, as a math teacher, I'm very aware that maths can be beautiful, but not to the degree that these sentences do not come across as slightly odd. So be careful with that, please. Okay, let's talk about the main body presentation. So to do that, let's move to this diagram here. All right, so with regards to presentation, the first thing I've suggested we consider is define key terms of new concepts or fundamentals of the project. A glossary might be advantageous, but it's not necessary. It's just a choice, and it might be advantageous. With regards to anything I suggest here, this is a template perhaps, or an overview. I'm not telling you how to map it out. And also, be careful with just defining the really obvious things like what is sine theta. So be careful. I use the phrase fundamentals to drive that home. You don't want to not define key terms, especially if you're then going to springboard off them, but be careful to go about defining everything. It comes across as a bit intense. Use mathematical and silly. Use mathematical language where appropriate. So check for sentences where there is a mathematical phrase to replace it. So for example, rather than saying that the line crosses the axes at, you could say intersects. Use correct notation and symbols. Do not use calculated notation. So for example, rather than using a power symbol like this as described here, you actually want to make sure that it is correct notation. I would use, this is what I'm saying here, I would use such things as math type or LaTeX. LaTeX in particular is one that I would find I judge as advantageous because it might be useful when you move on to university. But whatever you wish to use, just the basic equation writer in Word is advantageous. Do not mess around with this one. This is important with regards to marking in terms of the presentation part. Ask yourself whether you can integrate graphs, diagrams, tables for the betterment of your argument or development. This is something that is useful. So I would suggest to you, you read through everything that you've done and ask yourself whether the reader might have an advantage if they were to see it in a graph form or diagram, or to note the tables. These things are advantageous, in my opinion. Software, spreadsheets, etc. should be utilized if possible. Link to personal engagement. Okay, so when you are suggesting that you're going to use a piece of software, you can literally suggest why you are using that software in terms of your own personal engagement. Or you can describe the lack of software and perhaps maybe handwritten diagrams and so on and so forth as a result of whatever personal reason. And in so doing, you can kind of link this to personal engagement in the middle, in the main body of your work. So you can describe why you've chosen a software, why you're not going to choose a software, and so on and so forth. Or maybe you choose an interesting and different software because you've got specific practice with it for having used it in some sort of entrepreneurial or work experience setting, whatever you wish to do. Be aware that you can link that up. Appropriate degrees of accuracy is important. Don't round too much or vice versa. Give huge amounts of decimal places for things that are measurable by a normal tool and therefore is unnecessary. And explicitly define all variables. If you're going to convert something into a letter like M, let us know what it is. Is it mass? Is it something more specific than that? So please define your variables. Okay, we're getting through. Thank you for being patient. Okay, the main body, the mathematics. Let's look at the mathematics in more detail. So with regards to maths, you want to make it commensurate to the level of the course. You can feel the challenge of the course, and you want to make sure that the maths in your IA is linked to that challenge. Do not do something difficult that comes with a high opportunity cost. So that is to say, you pick a topic that's too hard and therefore it's too challenging to reflect on it, for example. What you want to do, or you're not as personally engaged, and that comes across. So be careful with regards to the challenge. Don't go too far. Depict that you fully understand the mathematics, perhaps by describing the steps. The reason I've colored this the same is because I've suggested in the past that you should definitely describe the steps that you're doing. This can depict that you understand. It also can link to this concept of not copying work. You can kind of give yourself a backup that you didn't copy it by being very descriptive with regards to the steps in the mathematics. I think that's important. You must be correct to the degree it does not ruin the flow and the outcome is logical. This is what I judge we can describe as correct. If you can still be considered correct if it doesn't ruin the flow and if the outcome is logical. So there's not something really strange in it, like for example negative velocity for throwing a ball at someone. Precision. This means no error, including significant figures, etc. Try to maximize this. I'm aware that IB consider that you can utilize friends and others to look at your work, to read over certain things, to discuss things, and perhaps therefore you can notice if there are any errors. If the errors decrease, you increase your precision. Multiple ways to come up with similar outcomes or describe how it links to other areas of mathematics. This is what I judge to be called sophistication. Try to maximize this where possible. You don't want to go overboard with this. A lot of the IA is about finding the correct balance for your research question. However, if there is another way to come to a similar conclusion, another method, you could mention it, you can consider it, you might even be able to depict it in your IA. Correct language for the age group, if not higher. So it's rigorous. This, I do believe, is a bit challenging, however. What you want to do is you want to pick a topic that is your level and maybe even a little bit higher, just to give yourself some level of interest. But it needs to be something that someone slightly younger than you could pick up and figure out. Mainly because you define things when necessary, it is step by step, it's logical, and so someone else could kind of look at it and work it out, even if they were a little bit younger than you. But you don't want to dumb it down to the degree that it's designed for someone younger than you, and therefore is not rigorous. So it's about balance. It's about balance there. So correct language for your age group, if not higher, rigor, but you kind of make sure that it makes sense, it's logical, things are well defined, it's clear, so that if someone slightly younger wanted to pick it up and with a little bit of work, figure it out, they could. And one of the main things, everything must be in your own words. Everything must be in your own words. I need not say that more. The main body, your graphs and diagrams. Okay, your graphs and diagrams. So include graphs and diagrams that are necessary for the argument or the structure of your IA. Please make sure you do that. You want to do that. That's advantageous. This is a whole point. I'm making this a whole point. The appendix should be used for large sums of data. That's what it's used for the large sums of data. If you have large sums of data in your appendix, you want to summarize it in a diagram or a graph, and that is what should be in the main body. Try and place diagrams and graphs close to the place they are cited. I'm making this clear purely because it's not very well. I would suggest against circumstances where you have a large paragraph of information and they have to scroll down to find the graph and then scroll back up to get back to where they're writing. You can see why that would be not advantageous for the reader. Try not to refer to the appendix for things that would otherwise strengthen your argument or aid in the flow of development. Right. So if it is something that you judge is actually useful to the flow of development or your argument, I would not tell the reader that they then need to go to the appendix to find it. It should be summarized in there right then, and that's that. That's the graphing and diagram section. Okay, with regards to the main body and conclusion, this is reflection and validity. Now, with regards to reflection and validity, I said, what logical conclusions could you infer from your findings? That's the first thing I would have in there in terms of reflection. Are they what you expected or different, and why? Did you actually expect what you found? Are there things you can do as a result of what you learnt that you could not do before? Can you consider any counter-arguments? And also, counter-arguments in terms of your conclusions. And also, can you link the outcomes or anything that you've found to different fields, different topics in mathematics? And this is where I judge you can definitely get to grips with something that you would have to tackle when you move on from the IB course in many fields. So for example, that this is not just in a mathematical field, you'll find these even in the social sciences. You want to consider such things as the validity of your methods, the data you had, the conclusions. I've stated here, for example, you can look at such things as the sample size, the duration of the research, the lack of the control group. Was there a control group or not? How the data was collected, precision of the measurement. Was there any human error? That is something that must occur in many IAs, arguably. Correlation versus causation. Is there a claim that is too far towards the idea that it's causation rather than just correlation? Lack of mixed methods. Are you making a claim because of the data you have, wherein actually you then need to go about interviewing or speaking to people to suggest it's true? Be careful of any claims you make that's based on mathematics. There perhaps more correlation. And external validity issues. So there is a sense that you always need to link it back to the real world. You want to link what you found to other situations, but be careful in not exaggerating it. Just because you found out something for whatever your investigation is does not mean to say it will apply in other areas, in other places, to other people, to other concepts, and so on and so forth. You've got to be careful of the external validity. That is to say, you've got to be careful of making conclusions about the degree to which what you have found, is related to other concepts, other types of mathematics, other groups, other people, and so on and so forth. Be careful about exaggerating the link to the real world situation. Okay, we've made it. We've made it to conclusion. So what would I have in my conclusion? First of all, I'll summarize what you have done in a couple of sentences. That's advantageous. Perchance include personal reflection, e.g. how did you find carrying out the investigation? How did you find it? Did you successfully explore your research question in a way that was engaging to you? Was it successful? Was it engaging? Did you enjoy it? Did you not? What was challenging? What was not? What would you do differently if you were to repeat the investigation again? Right, so a bit of reflection there again. And you can also further research. You can also suggest what further research you can do now that you have done your investigation. And in so doing that, you have your conclusion, you have an introduction, you have the types of things you should consider when doing the main body.